I don't, it's good afternoon still? Okay. Good afternoon, everybody. Okay, I hope Jitendra did my job easier. You all are awake. And I think I'm going to take you to the next level of discussions. Thanks QAI, thanks Zawad, and thanks Pradeep for making me come every year. It's my 4th year, I think. So I have been hearing, when I go out, I'm seeing the machine learning is becoming a very big buzzword or an event, I could say. And I'm also going to talk about that. So please excuse me if it's going to be a repetition. You may know many things, but then I thought that the industry is moving at a very fast pace, so there has to be some sort of a construct or a model around machine learning. So that's the thought process I used. So I represent Harman as a Chief Customer Success Officer. And just to, for people who, it's not a software company, but we acquired a software company called Delica, and that's how I represent the software arm of it. So Harman, what we do, sorry, you have that, this one. Who don't know Harman, it's a company in connected cars. It is in navigation, multimedia, and it's in lifestyle audio. We make branded audio products, sound management software for cars, homes, and the vehicles on the go. We also have professional solution as a LOB, which is into audio, lighting, switching. So the huge auditoriums which you see, the Yankee stadiums and other big stadiums of the world are lighted by Harman Professional Solutions. I represent the last arm of the LOB called the Connected Services. And here we are into cloud, mobility, analytics, and over-the-air updates for car and mobile. So that's the brief description about Harman. So we are a house of brands. And how many of you have heard these brands? AKG, Lexicon. Okay. So it's still new. We are a software fraternity, I know. So these are some of the brands which are big time in the sound and audio systems, and the AKGs and the JBLs of the world, Martins. So primarily, that's the history of Harman. So I just thought, let me walk you through. The technologies which drive Harman are into signal processing, automation and controls, live performances and lighting systems. Cloud analytics is the area where the Harman software piece comes. We acquired a company called Symphony Delica, so we got the whole software services part of it. Sustainability and experience design. So these are some of the key technologies which run the Harman system. These are the brand ambassadors of Harman. A.R. Rahman is one of the brand ambassadors of Harman from India, and we have other brand ambassadors from different countries who sell our systems, whether it's a lifestyle, audio, or video systems. So Harman got acquired by a company called Samsung, and today Samsung and Harman have synergized, and we have put scales, channels, R&D, brands, and talent. And again, on the software side, we have a lot of software being done in the car, connected car systems. We have done at different locations or venues and auditoriums. So it's been a huge journey for Harman and the Samsung in particular when they acquired us. So technically, $15 to $20 billion synergies have come up because of this. It's a leader. It has got a lot of awards. It's the IoT Partner of the Year award. The Google has identified us as a scaling partner. Intel, we have partnership to bring about high computing. Horton Networks, Gartner's, Zinnov, HFS Research, all the citations for the company. And we are competing with Hollywood, okay, in cognition. So are these names a little familiar? Okay, so these are some of the sci-fi, films which has been there in Hollywood, and we have tried our best to simulate this into our lifestyle audio and video system. So that's the whole backdrop on which I'm going to talk, in particular to testing. So this is just a construct I want to bring. I know since morning we have been talking about AI, we have been talking about analytics. Jitendra just talked about analytics, machine learning, and some of us are talking about deep learning. So I thought to put the story strong, we need to understand what is AI. So actually AI started with long time back and we forgot. And so AI is a broader concept than machine learning. And when I say machine learning, it's actually a subset of AI, so AI is broad. And the whole aspect of the game, as we all know, is making computers like humans, and that was the purpose of having AI. And we wanted to use neural networks, so that was the second thought process. Then the next question comes is, what is neural networks? So it's a series of algorithms. Just to So when we are trying to train the computers, when we're trying to use the neural networks, we are trying to make sure that the brain can recognize patterns, which you all know now, the pattern recognition. So we have learned to classify information. We have got neural networks to help us. We have got NLPs of the world to help us. We have got everything to help us to make sure that we can extract meaning out of data. So that was the first step. And we learn by examples, the second step. We are able to decipher and decode trends. That's the third step. And then we are going faster with more speed. So if these are the benefits, why not leverage this in testing? That was a thought process which I had. So when I started looking at the whole game, how do I try to create a model and a lot of things are happening, I thought that the most important thing is data. You garbage in, garbage out. So the very concept of data, if it is flawed, then there's no opportunity for us to use the data. So there has to be a learning little more layered, little more deeper, and then little more with more layered algorithms, and that's where a new concept came called DL. So we had AI, then we had machine learning, then we had DL. So what happens in a DL? A DL is nothing but a deep neural network. And in a deep neural network, more the layers, the more the ability of the neural systems to get more and more refined information. So deep learning networks can be used in testing. You can train them, you can program them, not only at the edges, but you can define items from them. Millions of data points you can get from deep learning. The most important example of deep learning is the Google Brain Learning, where it recognizes, incidents being shown in millions of pages. You have heard about Google Brain. And we are also trying to use different algorithms for the same. So net, I think the message is, if I have a clean data, if I have a meaningful data, and if I have a data which is not flawed, then all the work we are doing on creating a machine learning algorithm for testing is good. So if it is not, then it becomes a very tiresome and a wasteful exercise. So with this as a construct, I was looking at how testing can be used and how people are using testing, AI, machine learning as a service for different organizations, except for simple things like pattern matching or going closer to some data sets or trying to find out some product issues. These are happening as we talk. I could see a lot of work people have done. Outside the room, we could see people have used neural networks, people have used different types of learning systems. That was really wonderful. And people are doing a lot of end-user analysis because as a tester, you're supposed to be a user first. So user analysis is also happening in a very big way. You can get data from anywhere. Your log file statistics can get you data. Your pattern searches can get you data. Everywhere you can map and tell which is more important, like we talked about the targeted testing before. So you have to test where you can find and detect more defects. What are those gold mines for defects where you can test faster? So with this, ultimately, the whole system, whether we are a tester or a developer or IT professional, we are observing what is happening. We are interpreting it. We're evaluating all the interpretations and deciding which one to go for. This is the IBM Watson's slides, some of the parts which I'm using. So how do we become an expert? We used to have expert systems. An expert does something very similar to the cognitive process. He or she observes, interprets, evaluates, and decides against an environment. And the environment is huge. A lot of, the billions of connectivity of sensors which we saw. When the environment becomes used, what we have interpreted becomes a big challenge. So what we have interpreted and what the environment, there is always a misfit. And this is where I personally feel that IBM Boston has done a wonderful job of scaling the expertise to expand what is possible. So I think this is very key, that we should expand what is possible. And that is where we create a set out of our larger ecosystem. And Watson is creating that partnership, how people, all of us, can work with machines, that's computer, which, very key, enhances, scales, and accelerates. So the machine learning model, which I'm going to share out of my experience, the 6D model, is going to do exactly the same thing. It will enhance testing, it will scale testing to the next level of maturity, and it will accelerate testing. That means you're going faster to the market. You're going more closer to the market. What is this model all about? I've been in the industry for almost like 28 years. I found that testing can be well understood if I know my approach well, if I know what activities I'm doing in testing, at what level I'm testing. Is it at a unit level, at a regression level, at a system test level, integration level? And what am I learning in testing? Can my learning be patterned? If I have learned something in testing, what are my learning properties in testing? And if I have learned, I have a property, with each properties I have elements to learn. So I use the 6D machine learning framework for testing to make my job easier. I thought I'll share it with you. That I said that if I have to do machine learning, I should know where to approach. How can I put in approach? How can I put in activity? How can I put in level? How can I put in learning techniques? Different aspects. So then, this is a paper from University of Canada, and I have the authors also as references. They have done a very wonderful job. I thought I'll share this picture with you. If I have to do machine learning in testing approach, I can do a machine learning in black box, white box, and gray box. If I have to do machine learning in a category, I can do a lot of machine learning stuff in test planning itself. I can do test cost estimation. I can pattern the whole cost estimation model using machine learning. If I have to do machine learning in test case management, as most of the speakers have talked, I can do test case prioritization, which people are doing. I can do test case design the one which is most effective. I can eliminate test cases, not even optimize, test case reduction. I can refine the existing test cases, and then I can evaluate the test cases. So when I'm doing a test case management, I can do machine learning in all these sub-dimensions. So if you see this whole stuff, this entire machine learning can be put into 6 dimensions, 3 on the category side and 3 on the machine learning side. And each of these categories can be further broken into sub-dimensions. So my sub-dimensions are test planning, test case management, debugging. In debugging also, we can do it in a better way. Many of you are doing it. Fault localization, bug prioritization, and fault prediction, or defect prediction, which you do. The defect prediction you do is a machine learning dimension under the debugging category. We can do the same in testing level. We can do the same in acceptance testing, system testing, integration, module, unit, regression. These are the levels in testing. At every level, you can put a machine learning use case. Then in the machine learning category, you can do a learning technique through a decision tree, DT. You can do through artificial neural networks. You can do through genetic algorithms, GA. You can do through Bayesian learning, BL. You can use through instance-based learning. You can make clustering, you can make hybrids. So all these are the sub-dimensions under the testing learning technique. In learning property, when we train and do testing over and over again, the huge amount of data which we have collected, we can do a lot of training data properties there. Automation is one where we can make it semi-automatic or automatic. In learning systems, we can have supervision and non-supervision, other aspects of learning. And in time generalization, we could have a lazy, eager, online, offline sub-dimensions. So these are the whole canvas where we can put the machine learning in place. Let's see it one by one. So when I took the dimension testing approach, my sub-dimension was what you saw in the earlier slide, black box, white box, and gray box. And then I had a value outcome task. So this is what you need to record. If I've used the machine learning in these approaches, what is the value I get? If this is the general activity, what is the value I get? Similarly, in testing level, what is the value I get? So I have done experiments for 2 or 3 projects. I can't show the results, but it's a fully used project. In learning techniques, I can tell that I can use a data visualization tool for defect identification. Fine, what is the value you've got? I can correlate defects across applications and drive RCA, root cause analysis. I can conduct a machine learning kappa, a corrective action and a preventive action. I can cluster the test cases in groups using an NLP algorithm. I can do defect prediction, which we all do based on application complexity. So I think many of us have started using D4, and people are doing predictions. I'm aware people have started clustering test cases. I don't know about the machine learning kappa, but people are working on it. Let's see the learning property in testing, D5. Anything which you can predict, prevent, and you can automate is coming under this category. You miss the test coverage against RTM. You have a dead test case. The test case, you don't have a test case for change or redundant requirement. You have an unattended execution run on a test case which is not attended. You can identify the hotspots and execute the test case for application stability. So if you have done this sub-dimension, your D5 is done. You get the value. If you've done the earlier, the D4 is done, so on and so forth. That was a thought process which came. So dimension-wise, the first step is, if you're doing testing, identify your approach. We all know these terms. If you know you're doing black box, then try to use a description as the machine use case. If you're using white box, properties are your machine learning use case. If you're using gray box, you're going to combine the machine learning use case of black box and white box. In general activity, you can, as I said, use all of these machine categories. Testing cost estimation. When your cost is very important, as all the earlier speakers were talking about. So if you're doing a cost estimation, you need to have the right testing plan to tell that you can test in a minimum cost. If you're writing test cases, you need to prioritize it. If you're writing a test case, you need to map it to the existing test case. So it goes on and on. So fault localization, exact location of fault. Maybe you can put a failure mode cost effect analysis or FMEA type of a tool. You can run some machine learning use cases on that. Bug prioritization, yes, you can do it. You can prioritize the revealed faults or bugs based on severities. It's possible. Fault prediction. Your test, all of us as test engineers can debug and find where the potential fault is. All possible. So where does machine learning come? The value outcome task for test planning is I save the cost. For test case management is I prioritize the test case, I did a redesign, I refined it, I evaluated it. And for debugging, I've done the fault localization, bug prioritization, fault prediction. So my first table of D1 is done. So I have approached in machine learning some level of maturity. D2, that was D2, D1 is done. D3 is the testing level. There are technically 6 types of testing level where you can attempt to test. So if I'm doing an acceptance testing, I'm actually trying to check my requirement. If I'm doing a system testing, I'm checking my architecture. If I'm doing integration testing, I'm checking my subsystem design. So the typical V model which you have for each of the levels of testing you do, from the left to right, or the thought process can be used in machine learning. These are some of the new methods which have come. I'm sure this is the area we all have to go as a tester. Use of decision tables and trees. Use of artificial neural networks. I saw in one of the publication, how the movement of an ant is used to define a neural network strategy that was interesting. Use of genetic algorithms for machine learning. The Bayesian learning or the Bayesian probability theory of P, probability of A given B has occurred, probability of A intersection B by B. I think that's the starting point of creating your best possible path in doing the best possible testing. People are doing instance-based learning. Every test case scenarios and instances are created as a base for learning from them. People are clustering the test cases and inferring a lot of things from there. And some of them are using the hybrid methods of the earlier methods to do the learning techniques, which is the dimension 4 of the machine learning. In dimension 5, we are going a little farther. We are telling the software that it will be having a learning property. And in learning property, the subdimensions are your training data, your supervision time, and the time which you are generalizing. So when you are doing any type of learning, may it be supervision or a non-supervision or unsupervised learning, you have two phases, a learning phase and a classification phase. Learning phase is called the eager phase. You're eager to learn. And classification phase is the lazy phase. So we have to identify these phases in the learning systems. In online and offline learning also, there's a lot of time generalization which will be used for the purpose. So net-net, the degree of automation, the automation index, the areas which are not automated will shout for itself. The design system can be made automatic or non-automatic depending upon the needs. So this entire learning property in testing is a dimension number 5, which is a very good way to bring the system up. Dimension 6 is metrics. All of us have a big data of metrics in our organization. You name a metric, we do it, and we develop it. But what are we doing with metrics? Are we trying to build elements into the system to learn? What are we doing with our software specification? Your user stories, your FRS or SRS, for that matter, your requirement could be a learning element. Your control flow graphs within the system can have learning algorithm. Your call graphs can have learning algorithm. Your test case also is an element of learning. Execution data, the data which you get out of testing. Your defect reports on severity and business priority could also be the element of learning. Your test coverage data could be. So when you start machine learning, don't get too excited. Go step by step, D1, D2, D3. So at every step, you can start with D6, 2 things, D5, 3 things. We have a roadmap to do machine learning in our organization. So I have proposed that this could be a plausibly good roadmap. I'm still toying with this idea. I'm not too sure whether this is the best thing, but I thought I should share it with you. So at the end of the day, these are the 6 elements of the whole testing machine learning. And I'm sure all the people in the house are testers. How many of you are testers? I want to run a small commandment session because the technology is taking it a very great shape. Can you all stand up? I'm sorry. Can you all stand up? Okay. So as a tester, we are moving to machine learning. We are going a long way. So let's take an oath that this is the day we have to do something different. Can you all read aloud with me what is written on the slide? I am the tester. I am proud of it. I can so much solve the product. I am proud to be a tester. I can shift left. I can shift right. I can shift up. Though I am shot by the customer, I am a proud postman. I am the customer advocate. Louder, please. I am the center of the universe. I test because I love. I test not because I don't know to code. I test because I love. I have arrived. I can work with machines and can work with them in tandem, harmoniously. I am all along the software delivery chain. You can see me from concept to finish. I am the Shiva. I am the destroyer. I destroy the product and help the Brahma to co-create it. I don't have any religion, manual or automation. I'm learning it all. Try me out. Give me time. I can help and will help. I am a generalizing specialist. I am the king. I am the context imperial king. At the stroke of the midnight, when the whole IT industry is seeing job losses, no one can touch me. I have embraced the future. I have seen the future. Testers, Jindabad. Thank you. I was motivating all of you. Any questions? I've motivated you. Any questions? Thank you. Thank you, Pradeep.